Okay, so let's start the chapter on your diversity of matter by its physical properties. Now, basically, when we talk about physical properties itself, before we even start the chapter itself, let's break down what exactly are physical properties. So physical properties, the word physical means things that you can use your five senses to actually touch or measure, okay, to measure the whatever quantity that is. So it can be any kind of quantity such as your length, it can be your distance, it can be your height, it can be your time, it can be a lot of different things. And today, these few chapters that we're going through about is how are you gonna diversify all your different types of matter, all your different materials, all your things by its unique properties itself. Okay, so firstly over here. Now, why do we need to classify matter in the first place? Because we just want to make things simpler, because there's way many different types of materials or even matter itself. So by placing them into their groups based off common characteristics, it makes us very simple to, first thing, to compare your similarity and differences itself. Because it will make our life easier if you want to choose a suitable material itself, whether it is to make a table, make your computers itself, make your handphones, all of this, we need to choose specific properties. And therefore, by grouping them, we can actually identify and isolate the group that we want. And then we can put aside those that we don't actually need. Okay, so in lower secondary science, we will actually learn about the different ways to categorize them. One of the simple method is just to classify them into their different states, your solid state, liquid state, and your gaseous state. Okay, so the thing is, you need to remember, wherever we want to classify or group things together, we need to make sure that you have your similarities and differences. So these similarity and differences are your properties. So let's take a look at your properties over here. For solids, we have definite volume and definite shape. Similarly, for liquids, we have definite volume, but for solids, for liquids itself, they will take the shape of the container. And you'll notice that for gases, they will actually have no definite shape and no definite volume as well. So this one you can also have, you can also write indefinite volume. Indefinite shape. This one as well, you can also write indefinite shape. So basically just the opposite of your definite is indefinite. Okay, so the most common example that we can actually use would be your ice, water, and steam. Now, if you think about it, all three of them is actually water, but they're just water in different states. You have your solid state, your liquid state, and your gaseous state over here. So you can see based off your properties, we can confirm which material or which object belongs to which category itself. Now, there's one special one that I want to ask you all to have a little food for thought. Is plasticine over here. Now, plasticine or your Play-Doh or those kind of soft sand itself, pretty sure almost everyone has played with it when they were younger. If not, you can just go to those kind of shops and just buy one to play around with it, or even your school bookshop. Now, plasticine, when we actually press it and we shape it, you can actually form different shapes. And sometimes you can also take the shape of a container. So now the question is, if it has definite volume and it can also have a certain shape, why would it be considered a solid and why not a liquid? Okay, the thing is, it is not a liquid. Why? Because it has definite shape. Okay, the only change, better to write, the only change shape if a force is applied. Okay, so what this means is if I don't touch my plasticine, I just place it on the table itself, it doesn't behave like a liquid. It will stay in that shape unless we apply a force and squish it. And then basically we will actually change the shape of it. So unlike a liquid, if you pour a liquid on the table, it doesn't hold its shape. It will just spread all over the table, right? But if you place a plasticine on the table itself, it will still remain as the original shape. That is why the plasticine is still considered a solid and not a liquid itself. Okay, so this is just a way for us to categorize your based off your different states, your solid liquid states. solid, liquid, gas states. Okay, but now as we move on to upper side, we actually use different physical properties. So these are your unique properties itself. So wait, this is a different one now. So your physical properties are just properties that basically help you identify which material is your best or suitable one. So this one is actually categorized based off material properties. Okay. So we have a few one. Basically, all of them is actually just for us to choose the most suitable for the application that we want to use. You want to use the most suitable for a purpose. So for example, if you use plastic, plastic is very useful as a container because first thing, plastic is waterproof. However, we cannot use it for cooking. Okay, we should not use for cooking. Why? Because it will melt and burn when you heat it up. So you don't want to drink or eat your plastic, or we don't use it for cooking. For cooking, we'll use different materials such as your metals. So what makes metal better than your plastic is what we are gonna learn about today. Right? Firstly, we have density. Now, density, you can see is mass per unit volume, right? So you can imagine it's mass per volume. Okay, the unit volume is every time you have a per something, you always be accompanied by a unit. Okay, so it's always mass per unit volume. So density, we can use D. So if you write the formula, it will be D is M over V, mass over volume. Okay, now, basically, what is density? If you say my object is denser, which means your value is bigger, denser, or you can write more dense, which will be clearer. If it's more dense, it will sink. So when it sinks, it will go all the way down to liquid, it will just submerge fully. Okay? So if you are less dense, on the other hand, then you will float. Okay? So basically, density allows us to identify if something is floating or sinking when you put it in water itself. So the thing is, density don't always have to be inside a liquid. It can also be used to actually talk about your mass, because if you notice here, density and mass, they are linked together. They are in the same formula, right? So they are somewhat related over here. So let's first draw a diagram at the side. So this one we typically don't see in Singapore, we usually see in other countries. We will have power cables or electric cables that is hanging from some power lines. Okay, so this is your electric cables. Okay, so the thing is, electric cables itself, because they have the same volume. Okay, so they have the same volume. What happens is, if I use a denser material, what does that mean? It will have more mass. Because remember the formula that we wrote just now, D is M over V, right? So if I move the V over, I will have dV is M, right? So your mass is actually density times volume. Okay, so because of that, if I have the same volume, but I use something that is more dense, we'll see that if I use something that's more dense, my mass will also be more. So what does that mean? It means it will be heavier. So if you look at your electric cables over here, do you want the cables to be heavy? No, we don't actually want the cables to be heavy, because if your cables are very, very heavy, what happens is if some unlucky person decides to touch it, they will get electric shock. So we don't want that to happen. So your electric cables cannot be very, very heavy. They need to be light, but still suitable enough to actually carry electricity. So in this case, we actually use aluminium for your long distance electric cables. Now, why is that so? They are less dense than copper. So now, why do we talk about copper? This one is the one that is used for wires most of the time. So all the wires that you have in your handphone cables, your charger cables, or your laptops and stuff like that, all of these are usually made of copper. Now, even though it does not conduct electricity as well, so it means it still conducts electricity. So it can still have electricity flowing through. Just that, why do we choose aluminium? because aluminium is actually less dense, so you will be lighter. So your cables will not droop down and injure anybody if someone touches it. Okay, so you can think of it as, if you know that you have the same volume, then this means this. That's why you can see, actually, if you look at the formula, density, mass, and volume, these three, volume, density, and mass, these three are your keywords. So anytime you want to explain how come I am using aluminum and not copper itself, you need to say, because I have the same volume, aluminum is less dense, so it's the opposite of this. Aluminum is less dense, so I will have less mass, so it is lighter. So maybe I'll change this to the aluminum example, so it will make more sense to you. So let's say we use a less dense aluminum, and therefore you'll have less mass, so it will be lighter. So you can see, basically for science itself, when you want to explain something and you have a formula, all of these are your keywords telling you how to explain the question. So just take note. So you can just imagine my volume is the same. My density will be smaller. I will have less mass. So you can see this is your step 1, same. Number 2, decrease. Number 3, decrease. Therefore, lighter. So you can see, basically you're using the formula itself, just that it is now in words instead of using numbers to explain. Okay, next one. This one is nothing unfamiliar to most of us. First thing, melting point and boiling point. This is just the temperature where your object change state. But this is very, very useful because sometimes I want a material that can withstand certain temperature. So for example, table cannot choose something that melts easily. So it's like I cannot use chocolate to make my table, because if I rest my hand on the table itself, the chocolate will actually start to melt over time. Especially in Singapore, where your weather is very, very, very hot, your chocolate will actually just melt straight away and everything will just fall to the ground. So we don't use materials that melt very easily for tables. This is one of your physical properties that allows us to choose which material is more suitable. Okay, so even though, yeah, we know what's melting point, what's boiling point, but what's the purpose? Is to actually tell us, oh, we want something that can remain in solid state for a long period of time. That's the purpose of choosing something like this. Similarly, if you want to use a cooling fluid, like a refrigerant in your fridge, you usually have a low boiling point because you want it to be a liquid when cooled. You don't want it to be a gas. You want it to be a liquid itself, then it'll be useful. Similarly, another example. Okay, another example would be your hand sanitizer. Your hand sanitizer, when you squirt into your hand, it can be a gel or a liquid, right? But once you gain heat, it will vaporize. So when it vaporizes, it will cool you down, right? So because of that, you don't want your hand to be full of liquids. It's wet. Nobody likes that to happen. So hand sanitizer has a low boiling point. So that when it actually touches your hand and it gains heat from you, it will vaporize and bring away all the heat that you have in your hands. So because of that, you will feel very cool after you spray hand sanitizer on your hands. Okay? Next one, let's talk about strength. This is talking about how strong you are versus how weak you are. So typically when you say something is very, very strong, you need to be able to support a heavy load without breaking itself. So the thing is, the keyword here is without breaking. So if you break, you are weak. If you don't break, you are very, very strong, which makes sense, right? If your material, like iron or steel, is very, very, very strong, you can support a lot of heavy things without breaking itself. So even, let's say, the plastic that you have or the wood that you have on your as your tabletop, those are typically very, very strong because you don't want to place something heavy on the table and then your table just breaks, right? Your table needs to be stronger than whatever heavy object that you place on top of it. Because if you, let's say, use styrofoam box, the styrofoam box will just break straight away because it's very, very weak compared to iron or even like solid wood. Then those will be stronger than your styrofoam itself. Okay. So just need to be careful. Let's move on to your next page. So just do remember. Now, over here, we have what we call pure metals. Now, pure metals itself, they can be copper, they can be iron, they can be silver. Basically, there is something called a periodic table. And all the elements that you have, most of the elements on the left-hand side are all what we call pure metals. We'll learn about this more later in the year. So you don't need to worry too much about this. The tutor will talk more about this when you reach this topic itself. So the thing is, they have low strength. Basically, they are weaker. Okay? But the thing is, if you combine it with other material, you form alloys, right? So what are alloys? Alloys are, let me just write at the side. Alloys are mixtures of metal and other substances. Okay, they are mixtures. So the thing is, if you are a mixture, typically you are very, very strong. Okay, you are strong when you are an alloy. But if you are pure metal, you are not as strong as you think. So only by working together, you will be stronger, which makes sense, right? Because if you are doing things by yourself, it's very hard to get things done. But once you have all your friends coming in to help you with it, it will make it easier for yourself. You have higher strength. So all your bridge, all your, maybe even your stainless steel spoons, all the utensils that we use to eat, right? Those are also made out of steel as well, because steel is stronger than pure metals. And there's a saying in Chinese where it's not a saying, it's more like when people in the past, when they want to test the purity of gold, they will actually use their teeth to bite it, because pure gold is so weak that even our teeth is strong enough to actually break it. Okay, so the thing is, pure metals, they are very, very, very weak. Okay, compared to solid metals. Sorry, not solid metals, compared to alloys. But the thing is, even though we say copper, silver, and gold are weak, but that's only amongst metals. Compared to other materials like styrofoam box, perhaps the styrofoam box is even weaker. So this weak is actually just relatively weak. Okay, so maybe you can add the word relatively. So it's like when you compare it to another metal or to an alloy, it is considered weak. But if you compare it with other materials, it might not be as weak as you think. Okay. So next one. This one is very, very important. Huh? Write down. Is the only way, or is the, this is to identify whether the substance is a metal. Okay. So the thing is, metals all can conduct electricity. Can all conduct electricity because of free electrons. Okay. Then, or you can, yeah. So the thing is, that's why we use it for all your electrical cables and all that. So, but on the other hand, rubbers are what we call insulators, because they do not conduct electricity. So the thing is, maybe you can write at the side, all metals are good conductors of electricity. Okay, so all of them can conduct electricity. Okay, so only non-metals cannot conduct electricity. Okay, and similar to your thermal conductivity. Now, thermal means heat. So this is your heat conductivity. So metals, same thing. They are actually good thermal conductors as well. So they are good conductor of heat. So we use it for cooking and stuff like that. On the other hand, if we have poor thermal conductors, which is your insulators, such as wool, we use it for winter clothing. So we do not lose heat so fast. Okay, so don't worry too much about the thermal conductivity. The electrical conductivity is the most important one. Okay, then your magnetic property itself is the ability to attract magnets. So the thing is, magnets itself, there's only a few, which typically is iron, nickel, and cobalt. But most of the time we use iron and steel itself. Okay, so these two are the most common one. Basically, they can become Mannix. Basically, that's what it means. And this one, next one, I want you to take note. This is not strength. This is talking about hard versus soft. So the thing is, I need to see that you can withstand scratches and wear and tear. Okay, which is typically just say withstand scratches is good enough. So if, for example, you take your own fingernail and you scratch your skin, you can see a white mark, right? What does that mean? Your nail is harder than your skin. As long as you can scratch something, the one that is scratched is softer, the one that is not scratched will be harder. So typically, we will use diamond or titanium, which is very, very, very hard to scratch some other things. Okay, so the thing is, diamond is so hard, we use it for drills, we use it for cutters, so they can cut through like cement and other materials or even metals. So the thing is, because metals are so hard, right, we actually use diamond itself, which is even harder to actually cut through and slice all your different things. So if you go to a construction site, you hear a jackhammer, the one that they use to hit the cement, those, right? The tip of that device is actually made out of diamond as well. But those are not the diamonds that you see in the jewelry shop. These are the not so shiny diamonds that they found, and it was not big enough to actually form into a jewel. So they actually just coat it onto the tip of the jackhammer and use it to break all your different cement or your ground, the concrete and all that. Okay. Then last but not least, we have this table that we have down here. Now, typically for materials, okay? So for materials, we break it down into these 5 groups. And all of these 5 groups share a certain general property itself. And if you remember, the only way we can identify a metal is using this. Okay, so this is the identify metal method. Okay, very important, huh? Because if you notice the rest, all of them cannot conduct electricity. Okay, so because of these metals, the only way we can identify what's a metal is straight away through electrical conductivity. All right, then next for your plastics, fibers, glass, and ceramics, we have to look at the specific properties. Now, let's go down the list one by one. Huh? Transparency, plastics. If you look at your plastic bottles, some of them are transparent. If you look at a plastic chairs are opaque. That's why the word here is it depends. Similarly, for your fiber, there is different types of fiber itself. Some of them can be transparent, translucent. So there is no correct way to say that you can confirm which is a ceramic, which of the materials that they are. Next, we can also make use of your man-made versus your ceramics and all that. Okay, so the thing is, as long as you notice most of them here, other than metals, they are actually mostly man-made. So I want you to see the characteristics over here. Man-made materials are typically anti-corrosion. That's why if you throw away plastic without thinking, your plastic cannot biodegrade. So it will actually take up space and it cannot disappear or basically rot into nothingness. So that basically that is why there is the action where they say, oh, there's no more, we're not going to sell plastic bags. Please bring your own bag for your shopping and groceries now. Because if a lot of people just throw their plastic bags on the floor, in the drains, or even at sea, it will actually cause the sea and all your surrounding environment to actually be filled with plastic. Because plastic cannot corrode, it cannot rot. So all of these need to be handled properly so that we can recycle them or to actually dispose of them properly. Okay, so you need to be very, very careful about this. So basically for your plastic, fibers, glass, and ceramics, it's a bit hard to identify which is which. So you need to be very, very careful about all of this. Okay, so let me just go to the next page to write metal. This is your plastic, fibers, This is your glass. And last but not least is your ceramics. Ceramics are all your pots, those kind of porcelain, your clay, stuff like that. So this is your clay, yeah, your porcelain, and stuff. Okay. Fiber, on the other hand, can be your strings. It can be cotton, etc. Okay. Plastics got all your different types. Now, high density itself, most of the time, glass and ceramics have high density. And typically, if you have high density, you technically have high melting point, but this is not confirmed. So just be careful. And they are very brittle, which means that they will break into many pieces easily and shattered. Okay, and can be molded. When you say can be molded itself, you can change the shape. Change shape easily. Okay, so you can see all the different details over here. So all your different properties is basically listed all over here. So if you need to, feel free to come back to this. Now, I just want you to note this is not the entire properties. There's also your flexibility, ability to bend without breaking. Okay, then you also have your ductility, the ability to be drawn into a wire. Now, this one is a bit special, but so you just need to note fibers are not ductile because fibers are already in a form of a wire or a string itself, right? So they are not considered to be ductile because you cannot change it into a wire when it's already a wire. Does that make sense? Just note that fibers are not ductile itself. And you might see this word malleability. It's the same as the can be molded part. Can be easily molded or change shape. Okay, so you can say like Play-Doh is malleable because it is easily molded and stuff like that. So there's a lot more different properties itself. This is just some of the many different properties. So do take note of all of these properties itself. Then when you do the tutorial, it'll make more sense to you when you use it in the application itself. So for now, just need to know. So just be curious around the things around you. Look at your pen, look at your pencil, look at the things, look at your, just take a look at the things around you in your surroundings. Ask yourself, are they metals, plastics, fibers, glass, or ceramics itself? And a weird fact is humans, living organisms, are typically considered to be fibers. Because if you eat meat, when you tear your meat, you'll notice that some of them are a bit stringy, right? Those are actually your fibers. So weird fact to know. Or even your plants, if you actually look at your leaf of your plant, and if you are destructive enough, if you tear open the plant, the leaf, you'll notice that the leaf are also in strands or strings, right? So technically, living organisms are considered fibers. Yes, weird and creepy fact. Okay, but apart from that, you can just take a look at the things around you. You can think about it. Are they metals, plastics, fibers, glass, or ceramics? How did you confirm whether they are which is which? Which property let you identify that they are plastics or glass? Because plastics and glass, they are quite similar. So you can actually take a look at those. Or even your ceramics. What makes them different from the rest? Why is your ceramic not glass? Because ceramics are all opaque. Because if you notice, ceramic and glass, they share very almost the same properties, right? But the only difference is ceramics are opaque, while glass is clear or transparent if you have your tinted glass. Okay,